Welcome back to the deep dive. Okay, today we're diving into something that it might just give you a full-blown identity crisis, but honestly, in a good way. You ready?
Oh, absolutely. Always ready to question my fundamental existence. Lay it on me.
All right, imagine this. Y- You think you're you, right? This unique individual. But what if, like, 99% of the genes actually running the show, controlling your weight, your mood, even how often you get sick, aren't even human?
Ah, the microbial overlords.
Exactly. You're basically just prime real estate, a walking, talking apartment complex for trillions of tiny tenants in your gut.
It's the biological reality, isn't it? I mean, we have maybe 20,000 human genes. The microbiome, we're talking potentially 3 million microbial genes. They outnumber us massively.
Utterly outnumbered. And that sheer power imbalance leads us straight to what might be the biggest lie we've all kind of swallowed about how our bodies work.
Oh, I think I know where you're going with this, that comforting little story.
The one where you take antibiotics, feel rubbish for a bit, but hey, don't worry, your gut is tough. It just bounces back. Everything goes back to normal in a few weeks.
Yeah, that one. And it's just fundamentally not true. It's a dangerously misleading, actually.
Completely false. So if the damage is so bad, why isn't this, front page news? Why is it still downplayed?
Well, I think it's because the damage isn't just about, say, reducing the number of microbes temporarily. It's about extinction.
Extinction inside us.
Permanent extinction. Antibiotics can completely wipe out specific, crucial strains of good bacteria forever. And that empty space, that niche, it doesn't just stay empty.
Okay.
It gets filled, often by less desirable microbes, sometimes even antibiotic-resistant ones. It's like bulldozing a vibrant, essential neighborhood and having invasive weeds take over the plot permanently.
That's a powerful image. And it's not just the antibiotics we get from the doctor, is it? There's other stuff messing things up.
Oh, absolutely. Think about things we encounter maybe more regularly. Corticosteroids, like prednisone, major disruptors. Then there's the obvious stuff. Diets loaded with ultra-processed junk food basically starve the good microbes. And then there's the less obvious, like glyphosate.
Roundup, the herbicide.
The very same. It's actually patented as an antibiotic. Its mechanism of action is antibacterial.
Yeah.
So chronic exposure through the food chain, it adds up. All these things contribute to what we call dysbiosis.
Dysbiosis, the imbalance.
Exactly. And that imbalance is the slippery slope towards chronic inflammation, autoimmune conditions, metabolic problems, leaky gut, the works.
Okay, let's talk about this microbial Jenga tower idea, because it's the loss of specific players, these keystone microbes, that really makes the whole thing unstable, right?
That's the crucial concept.
Yeah.
You pull out one of these foundational pieces, these keystone species, and the entire ecosystem can start to wobble or even collapse.
And that collapse looks like what? Inflammation?
Yeah, inflammation ramps up. Your risk for autoimmune diseases climbs. You get that leaky gut where stuff that shouldn't cross the gut barrier does, plus the bad bacteria that take over. There's thieves.
Thieves.
They steal nutrients from your food before you can absorb them. So you can be eating well but still end up with deficiencies because the wrong tenants are intercepting the delivery.
Wow. Okay, so let's name names. You mentioned there are some major keystone players that are just missing in huge numbers of people today.
Yeah, the numbers are frankly pretty shocking.
Right.
Let's start with one that's particularly vulnerable to antibiotics.
Yeah.
Prevotella.
Okay.
Estimates suggest it's missing in maybe 70, even 80% of people in Western societies.
Oh.
And it's not trivial. Prevotella is really important for helping manage blood sugar. And, get this, it helps your body break down and get rid of oxalates.
Oxalates. Aren't those the things that form kidney stones?
The very same. So missing Prevotella could be a hidden factor in kidney stone risk for a lot of people.
70 to 80%. That's huge. What's next on the missing list?
Next up is Akkermansia mucinifera. Bit of a mouthful.
Sounds important.
It really is. It's deficient in maybe 40 to 60% of us. It's a main job. Maintaining the protective mucus layer lining your gut.
The gut lining, like the barrier.
Exactly. If Akkermansia isn't there in sufficient numbers, that mucus layer thins out, becomes less protective. And that's strongly linked to metabolic syndrome, obesity. Basically, losing your first line of defense.
Okay, so Prevotella for blood sugar and oxalates, Akkermansia for the gut lining. Who else is AWOL?
Then we have Faecalibacterium prosnitzi, another lovely name,
Charming.
missing in perhaps 30 to 50% of people. This one is a powerhouse for producing butyrate, a short-chain fatty acid that's incredibly anti-inflammatory.
So lose this one.
And inflammation tends to go up. Your risk for inflammatory bowel conditions, other autoimmune issues, it increases significantly. It's a key peacekeeper in the gut.
Right. Okay, one more you mentioned, the one that explains salad struggles.
Ah, yes, ruminococcus, missing in maybe 50 to 60% of people. This group of bacteria is essential for breaking down certain complex plant fibers, cellulose-resistant starches, the tough stuff.
The stuff in it, like a big leafy salad?
Precisely. If you've lost your ruminococcus species, you literally lack the machinery to digest those fibers properly.
So what happens?
Bloating, gas, misery.
Massive, painful bloating. You eat a healthy salad and you feel awful. So you start avoiding vegetables. This might be a big reason why some people feel dramatically better on, say, a carnivore diet.
It's not the meat necessarily, it's that they stopped eating the fiber they couldn't digest anymore.
It's a very plausible explanation. They removed the trigger for the bloating because the digestive crew, ruminococcus, clocked out permanently.
Okay, those numbers are bad enough, 50, 60, 80% missing key players.
Yeah.
But you said there's one that's even worse, the real shocker.
Yeah. This is where it gets almost unbelievable. We're talking about a species called Lactobacillus reuteri.
Reuteri, okay.
The data suggests this one is missing in 95 to 96% of the modern human population.
95%, that's basically everyone.
Practically everyone. But here's the kicker.
If you look at the gut microbiomes of wild mammals or human populations who haven't had exposure to modern processed foods, antibiotics, the whole modern lifestyle package, they almost universally have it.
So we're supposed to have it. It's like a standard piece of equipment we've lost.
It seems that way. It looks like it was a universal, maybe obligatory member of the human microbiome that we've somehow managed to almost completely eradicate through modern living.
Okay, what makes L. reuteri so special then? Why is losing this one the ultimate missing link?
It has a couple of really unique, game-changing functions. First, territory. Most beneficial microbes set up shop primarily in the colon, the large intestine.
Right.
That reuteri is different. It colonizes the entire length of the gut, both the 24 feet of the small intestine and the colon.
The whole tract. Why does that matter?
It matters hugely for preventing something called SIBO, Small Intestinal Bacterial Overgrowth. That's when bacteria that should be in the colon start growing rampantly in the small intestine, causing all sorts of digestive chaos.
And SIBO is common, right?
Shockingly common. Some estimates suggest maybe half the U.S. population struggles with it. Having L. reuteri policing the small intestine is likely a key defense against SIBO.
So it's like a microbial border patrol for the small intestine. How does it do that?
This is its second superpower. L. reuteri produces its own arsenal of natural antibiotics. They're called bacteriocins.
Okay.
It makes at least 7 different types. And the amazing thing is, these bacteriocins are incredibly specific. They target and kill particular bad guys, like the types of E. coli or Klebsiella, often involved in SIBO, but they leave the beneficial microbes completely unharmed.
Wow, like smart bombs for bacteria.
Exactly.
Got
It's
it.
targeted warfare. Losing this internal defense system, this precision antimicrobial producer, is very likely a major reason why SIBO has become such an epidemic.
Okay, that's impressive. Colonizes the whole gut, makes targeted antibiotics. But you hinted there was something even more profound.
There is. And this connects directly to how we feel, how we interact, even maybe how we look. The most significant role of L. reuteri, arguably, is that it signals the body to increase production of a hormone called oxytocin.
Oxytocin. Wait, the love hormone? The bonding hormone?
That's the one. A single species of gut bacteria influencing the levels of this incredibly important high-level hormone.
How is that even possible?
It stimulates specific pathways, likely involving the vagus nerve, that communicate directly with the brain, prompting the release of oxytocin from the hypothalamus.
So losing this microbe means we're potentially deficient in oxytocin.
I strongly suggest that, yes. And oxytocin does way more than just bonding. It's a powerful anti-stress hormone. It directly lowers cortisol. It promotes wound healing. And fascinatingly, it's been shown to increase skin thickness and collagen production.
So it's involved in stress, connection, healing even, skin, this one microbe.
It seems so. Losing it potentially impacts our ability to manage stress, form social bonds, heal efficiently, and even maintain youthful skin. It's huge.
This is starting to sound a bit like science fiction, which I guess leads us perfectly into the slightly weird mouse experiments.
Ah, yes. The accidental fountain of youth discoveries at MIT. It's quite a story. They were a cancer research group, not looking for anti-aging effects at all.
Right. They gave L. reuteri to mice, probably hoping it would, I don't know, fight tumors.
Something like that. But the first thing they noticed, officially reported in their papers, was that the mice developed, and this is the quote, Rich and luxurious fur.
Rich and luxurious fur. Okay, not quite cancer shrinking, but memorable.
Memorable, yes.
Yeah.
That was the first clue. Something unexpected was happening. Then the findings just kept getting stranger.
Wow.
They found wounds on these mice healed in literally half the time compared to controls.
Half the time.
Then came the really startling observation.
Oh.
Older mice, given L-reuteri, started acting.
Mm.
Young again, they regained youthful muscle mass, their activity levels increased, their immune systems perked up, even their reproductive functions were restored. Old mice basically got rejuvenated.
Okay, this is where it gets funny, right? The lousy diet test.
Yes.
Yes.
To see how robust this effect was, they put mice on a diet designed to mimic a terrible human diet, basically. Mouse junk food.
McDonald's for mice.
Pretty much. One group got the lousy diet. The other group got the lousy diet plus L-reuteri.
Mm-hmm.
The control group on just the lousy diet, they got fat. Their fur became dull. They got sluggish, aged quickly. Typical response.
Uh-huh.
But the group on the same lousy diet, but with L-reuteri added, they stayed slender. They maintained their muscle tone. They kept their shiny fur. They remained active and youthful.
So the microbes somehow protected them from the worst effects of a junk food diet.
It strongly suggests a profound metabolic shift. It seemed to mitigate many of the negative consequences, keeping the mice in a more youthful, healthier state despite the poor diet.
That's kind of incredible. But okay, these are mice. Does any of this translate to humans? Did we get luxurious fur too?
Well, maybe not the fur part, quite so dramatically. But yes, surprisingly, many of these effects have been corroborated in human studies. The results are pretty remarkable.
Like what? Give me the highlights.
Okay, in older men over 50, supplementing L-reuteri led to significant gains in lean muscle mass, up to 13 pounds in some studies, and increases in strength by as much as 50%.
Wait, with minimal exercise? Did you say minimal exercise?
That's what the studies reported. Minimal exercise. Think about what that means for combating age-related muscle loss, sarcopenia. It's potentially revolutionary.
That's insane. Okay, what else for humans?
For older women, reports included restoration of vaginal moisture and sensation, increased libido, which apparently led to some, shall we say, surprising feedback for the researchers.
I can only imagine. Any cosmetic effects like the skin thickness thing?
Yes, people reported noticeable improvements in skin quality. Smoother texture, reduction in fine lines like crow's feet and smile lines. That seems to tie back directly to the oxytocin effect, boosting dermal thickness.
Okay, and the metabolic effect. Did people on L-reuteri stay slender like the mice?
This was really interesting. People often lost significant inches from their waist circumference, up to 8.5 inches in some anecdotal reports, but often without losing much actual weight on the scale.
So body recomposition, losing fat, gaining muscle.
Exactly. A shift towards a leaner, more muscular physique, even without major weight changes, mirroring that protective effect seen in the mice.
Wow. Any other big human benefits?
Sleep. This was a big one for many. People who'd struggled with chronic insomnia for years reported suddenly sleeping deeply and reliably 8-9 hours straight.
Just from this one microbe.
It seems to have a profound effect on regulating sleep cycles for many. Some people, especially when combining it with other beneficial strains, found they were sleeping so well, like 12 hours, they actually had to cut back.
Okay, I'm sold. Where do we get this stuff? But you mentioned earlier, supplements aren't really the answer.
Right. That's the catch. Commercial L-reuteri supplements, like the chewable tablets for infants, contain tiny doses. You need to take, I don't know, maybe 30 or 40 tablets a day to get near the dose used in these studies. It's just not practical or affordable.
So the therapeutic dose is really high.
You're aiming for something in the ballpark of 300 billion live microbes per serving. You simply can't buy that concentration off the shelf.
So how do we get it then, if we can't buy it?
You have to make it yourself.
Right.
By creating a highly concentrated single-strain ferment. It ends up looking a bit like thick yogurt, but it's not yogurt in the traditional sense.
Okay, DIY biohacking. I like it. What's the secret? Just letting it sit out.
No, definitely not. The absolute key is precise, prolonged fermentation. You need to ferment it for exactly 36 hours at a constant temperature of 99 degrees Fahrenheit, or about 37 Celsius.
36 hours at 99 degrees. Why so specific? That's body temperature.
Exactly. At that optimal temperature, L-reuteri doubles its population roughly every 3 hours. Over a 36-hour period, that allows for approximately 12 doublings.
12 doublings.
That exponential growth is how you get from the few billion microbes in a starter capsule to the hundreds of billions that therapeutic 300 billion count in your finished ferment. It's a 1,000-fold increase. You absolutely need a reliable way to hold that temperature, like a yogurt maker or sous vide setup. Room temperature won't cut it.
Okay, precise temperature, precise time. Got it.
Yeah.
What's the actual recipe like? Is it complicated?
Surprisingly simple, actually. You need your starter culture, usually 1 capsule or tablet of the correct L-reuteri strain, like ATCC PTA 6475 or DSM 17938. You need a prebiotic fiber to feed it. About a tablespoon of inulin works well. And you need a base organic. Half and half is often recommended.
Half and half, not milk.
Half and half seems to work particularly well for getting a thick, rich ferment. You start by making a little paste, crush the tablet or empty the capsule, mix it with the inulin and just a couple of tablespoons of the half and half. Get it smooth.
Activate the bugs.
Exactly. Then you stir that paste into the rest of the quart of half and half. Put it in your temperature-controlled device, set it to 99 degrees FAF, and leave it undisturbed for 36 hours.
Then chill it.
Then chill it thoroughly in the fridge. Once it's cold, it should be thick, almost like Greek yogurt. You typically consume about a half-cup serving per day.
And the best part, the continuous supply.
Right. Once you've made your first batch, the finished ferment is now incredibly concentrated. You just use 2 tablespoons of your previous batch as the starter for the next quart of half and half. Add the inulin, ferment again.
Yeah.
It becomes very inexpensive and sustainable.
A continuous fountain of youth, or at least microbial restoration, brewed in your kitchen.
It's a practical, powerful way to reintroduce something vital that modern life seems to have stripped away from almost all of us.
Okay, so let's pull back for the big finish here. We've seen the evidence. Bringing back just this one microbe, L. reuteri, can potentially restore muscle, libido, skin quality, sleep, maybe even protect against bad diets. It influences oxytocin, the love hormone. So the final, maybe slightly unsettling thought. If 95% of us are missing the microbe that literally floods our bodies with the hormone for bonding, empathy, and connection, what has that done to us as a society?
That's the million-dollar question, isn't it? We're living through times of record social isolation. People report feeling lonelier than ever. There's data showing concerning rises in narcissistic traits, particularly since around 2020.
Yeah.
Is it completely crazy to suggest a link that maybe part of our social malaise, our difficulty connecting, our empathy deficits could be downstream from a widespread, biologically driven oxytocin deficiency caused by losing this one crucial microbe?
When you put it like that, it sounds almost plausible. The studies you mentioned showed restoration boosted feelings of affection, desire for companionship.
Exactly. Increased generosity, stronger bonds. If your baseline internal chemistry is pushing you away from connection because the oxytocin signal is weak or missing, how hard does that make it to build a connected, empathetic society?
So maybe the solutions to some of our biggest social problems aren't just political or technological. Maybe they start in the gut.
It's a provocative thought, certainly. Could it be that we can't effectively tackle issues like loneliness and declining empathy until we first address this massive hidden microbial deficiency? Maybe. Just maybe. Fixing the world starts with a daily half cup of really weirdly fermented dairy.
A strangely fermented love potion for humanity. Definitely something to chew on. Thanks for this deep dive.
My pleasure. It's fascinating stuff.